This video is just a short refresher on relations. That's how we started chapter 3, talking about relations. But it's a short refresher before the next clump, the finale, the grand finale of chapter 3, where we talk a little bit more about relations and get into the idea of equivalence relations, which is going to be useful going forwards. So this should be review for you. Recall a relation, capital R, from some set A to a set B. Remember, we talk about relations as sets of ordered pairs. So we're going to have an element is in that relation. Remember, this is the Cartesian product, all the ordered pairs from those. And R is going to be a subset of that. So an ordered pair is in the relation if and only if, again, we say the element A is related to the element of B. And again, we talked about relations like the less than sign, the relations like the equal sign. We can also have relations like functions. Okay, functions are just specific cases of relations that, again, are defined for the whole domain. And each input only has a single output, whereas relations, that's not necessarily the case. It's the case for the relation of equality. It's not the same for the relation of inequalities. So again, just defining some things you should know already. How can we write the set of domain and range? I'm going to write the domain set, and I want you to fill in the range set. The domain is going to be all the inputs such that there is some output here. So AB is in R for some B and B. Now notice that the definition of domain here is different from the definition of domain for a function. That was one of the requirements of functions, right? Relations are more general than functions. Functions, every element needs to be defined. Here, relations, that's not necessarily the case. So a relation, the domain is just going to be all the elements that are defined, essentially, all the elements that have some output. So I'm hoping you could pause the video and come up with a very similar definition for range. It's going to be the set of all possible outputs, such that, again, AB is in R. Oops. Forgot to write that part down. AB is an element of R for some A and A. Okay, so let's do an example, and then we'll be done. So lots of writing here, so I didn't want to write it. So I listed some courses made by some fake students, listed as follows. So Jason's taken those 3, Jingy's taken those 3, and Bob's taken 2 classes. Create an arrow graph, which is also known as a digraph, which stands for directed graph, showing the relation R. And here we're going to define relation R, ARB, if student A is taking class B. All right. So here, R is going to be a subset of A cross B. The set of all students, Cartesian product, with a set of all classes. And we're going to create an arrow graph to show this. So again, let's call this A, let's call this B to make things a little easier. Usually we write A on the bottom and B on the top, which feels a little backwards to me, but it is what it is. And then we're just going to have dots for each element in A. So this will be the Jason dot, and this will be the Jingy dot, and this will be the Bob dot. Similarly, everything in the output as well. We'll have CS 310, CS 320, CS 330, math, I hope I have room for all of this, math 200, math 254, oh, and somewhere over here, we'll have math 153. So all we do here is draw arrows showing the relation. So Jason is related to this class, in this class. I'm going to use different colors just to make it easier to read, but you don't have to. Jingyi is also in CS 310. She's in Math 200 and Math 254. And then Bob is in 153 and 320. All right. And that's a digraph. That's an arrow graph. Just shows relations. So you can see, right, this is very definitely not a function. Everything in the input is defined, which is good. But right, every single thing in the input has multiple outputs, so this relation is very much not a function. It is surjective, though. If it were a function, it'd be surjective. But again, it's not injective because there are more than one person taking most of these classes. All right. Well, I guess it's surjective if we define B to be this set. This is kind of, well, if B is a set of all classes at the college, then I guess it would not be surjective. Anyway, depends on what we define our domain and codomain, but that's the idea for relations. Again, this is just a quick refresher video before we go on to the next video, which is when we're really going to start talking about more in-depth things for relations. Let me know if you have any questions, and good luck.